All right, hi everybody. So in this video, I'm going to help us to figure out how to use our TI-84s to find a slope at a particular point. So we have some function, f of x equals 3e to the 2 sine x plus 1. And on a calculator style paper or on really any style paper, you may be asked to find a particular slope at a point. You may be asked to find the actual derivative. You may be asked to find a tangent at a point or the equation of a normal. All of these things require us to do the same thing. So first off, we can find the slope at a particular point by graphing it. So I've gone into my y equals section here, and I've got this thing graphed, and I'll just go ahead and press graph, and we'll see that this is a weird looking function. It's going to take some time to draw. Now, I'm going to let it finish drawing, and I'll kind of talk over top of it. But if I didn't want it to continue drawing, and I thought, oh, this is taking forever and it's not what I need, or it's not the zoom, I would press second function and then on, and that would stop the drawing from occurring. But the drawing has finished because the little wheelie's gone there. So if I wanted to find the slope at a particular point, so I'll find the derivative of f at some value x equals a, I can just pick any value I want. I'll do second function, trace for calc. I'll choose option 6 for my derivative. And now it's going to pull up my trace, and I could trace along, or I could simply type in a value. So if I want to know the derivative at pi, I just type in pi and hit enter, and it's going to go ahead and give me the derivative of 3.1415927. Strange. Oh wait, no, that's the x coordinate. Ha! The derivative is -6. And if you've taken the derivative by hand and substituted in pi, you should see how we're going to get -6 as well too. But that would be useful because we would use that particular derivative as our slope of our tangent, or we would use 1 over -6 for our normal. So if this was our slope of our derivative at that point and we wanted to find the equation of a normal, our slope of our normal would be +1 over 6 instead of just -6. Now there is a shortcut for finding tangents a little bit quicker though. So that's how we can use a graph to find f of a. While I have this graph pulled up, I'm going to answer the question about finding a tangent. So if I wanted to find the equation of a tangent at a particular point, I'm actually going to use the draw feature. So draw is right above program. So I'll press second function draw, and I'll scroll down to option 5, which is tangent. And it brings up that same trace. So I can trace back and forth and then hit enter and select, or I can simply type in a number. So suppose I wanted to know the slope of my tangent at x equals, or the equation of my tangent at x equals 0. Now it'll draw the tangent on the graph for me, which is nice, especially if you have to figure out intersection points of multiple tangents. And it will give me the equation of the tangent underneath. So you can see x equals 0 was where the tangent was drawn from, and the equation is y equals 6x plus 4. I realize that looks a heck of a lot like 6.0000003x plus 4, but just trust me, it's 6x plus 4. And that has to do with the resolution of your calculator. So that saves a hell of a lot of work, sorry, heck of a lot of work, because we don't have to use the y minus y1 and mx minus x1. I think I'm going to have to mark this video not safe for kids now that I've said HE double hockey sticks. Huh. Anyways, that's one thing I want you to be able to do with your graphing calculators. But let's see how to do it without having to generate the graph, because remember, that took some time. So if I'm just in my regular calculator mode, and I wanted to find the derivative of something, I would just press math 8, and I would take the derivative of whatever's in the brackets at an x value of whatever value I typed there. So let's take the derivative with respect to the variable x of 3e to the 2 sine x plus 1. And I'll make sure that my entire function that I'm looking to find the derivative of is typed between those brackets. And at is what the vertical line means. So let's do this at x equals 0. Now we already know from our previous work that at x equals 0, the tangent had a slope of 6. So this should return me with an answer of 6. And it does. Now I do want you to notice that it's going through the shortcut of actually calculating the graph around a particular window and measuring from that. So it's not doing the derivative from first principles and substituting in. It just explicitly is, it's still pretending to draw the graph in the background. So we would interpret this as 6. So those are two ways of using your calculators to find derivatives. On the next video, I'll show you how to use your calculator to draw a derivative.